atria. Okay? That's one. It starts off the impulse, and then it spreads that impulse throughout both of the atria, the right atria and the left atria. Once the impulse has spread throughout both of the atria, next thing it sends the impulse to the AV node. Okay? So next one is AV node. Atrioventricular node. I'll come back to the figure and the comment. So the second part, or the second pathway, is the AV node, the second segment. Atrioventricular node, AV node. Location, it is in the right atrium, but it's at the junction where the right atrium will turn into the right ventricle. Does that make sense? At the junction of right atrium and right ventricle. But it is still in the right atrium. Okay, if I had to pick one chamber, I would not say that it is in the right ventricle. It's still in the right atrium, but at the border. Function slows down the impulse. It slows down the impulse. So basically, your SA node is, let's say, firing 200 beats or 200 per minute. Is your heart rate 200? No. Okay. So AV node slows it down. It holds the impulse before it gives it to the next phase or next part. Okay. So it slows down the impulse. Transfers or gives the impulse to bundle of His. So the third segment is bundle of His. Location of the bundle of His. Interventricular septum. So the bundle of His is located within the interventricular septum. Its function is to transport the impulse to Purkinje fibers or PJ fibers. To the PJ fiber. It's a conduit. It just gives it to, it collects it from the AV node and gives it to the PJ fibers. I'll tell you just. Now, the last segment is the PJ fibers, which stands for Purkinje. Purkinje, Purkinje fibers. Okay? So the PJ fibers, Purkinje fibers. Purkinje fibers are located with the ventricles, left and right ventricle. Function spreads the impulse throughout the ventricles. So Purkinje fiber just spreads the whole impulse throughout the ventricles. Now, certain comments about, I think the figure, this is A, this is B, this is C, and this is D, if I recall correctly. But we'll look at the next figure. Comment. The SA node is called a pacemaker. SA node is called the pacemaker. AV node, remember I told you, slows down the impulse. Why does it slow it down? Purpose of slowing down impulse. Gives the ventricles enough time to fill with blood. The reason the AV node slows down the impulse, it's so the ventricles have enough time to fill with blood before they start contracting once again. Because when the impulse comes, that chamber or that segment starts contracting. Okay? The impulse causes systole to occur. Bundle of His. Now, bundle of His has two segments. So you have, it goes like this. You have the common bundle of His, okay? Common bundle branch or common bundle of His. And then you have the right and the left bundle branch. Okay. So the bundle of His first starts out as a big bundle, then it splits into two smaller bundles. Because one will go towards the left side of the heart, one will go towards the right side. Okay? So you have common bundle branch, and then you have a left and right bundle branch. Okay? There's no comment. I can't think of any comment right now about a PJ. I think I said stuff when I was explaining. So right here, A is the SA node. As you can see, right here is the SA node, and it starts off the impulse, spreads that impulse toward the both atria, and that impulse is now given to the AV node. Okay? AV node slows it down, and then it gives it to the bundle branch. Now, you could see this part, and then you could see this part. So, C is bundle branch, bundle of His. Okay, but the red part would be the common branch, and then where it starts splitting would be the left and right bundle branch. Does that make sense? And you can see the entire thing is located within the interventricular septum. And now D is the PJ fibers. As you can see from here, now it's the PJ fibers, and it spreads the impulse throughout the entire ventricles. Does that make sense? Yes?
What was the red again?
The common bundle branch, and then you have the left and right bundle branch.
All the impulses.
Okay, go take a 10-minute break, then we'll start the blood. So I'm hoping we'll still get out by 12:30. Can you close the camera?
There's already